Hello, welcome to the final session of First Day of ZCon 2 on Zcash protocol and implementations. I'm Jack, or Strad, I answer to both. I'm a cryptographic engineer at ECC, and I try to write crypto when I can, but mostly I end up herding cats in the zcashd implementation.
And I'm Teor. I am a Rust systems engineer on the Zebra team. And yes, I herd cats in the Zebra implementation and try and fix very tricky bugs and try and support our cryptographers with good abstractions around their code.
Yeah, so it's funny thing, like what has been happening, because it has been a bit of a year, to say the least. And yet we have done a reasonable amount in it, despite everything going on. I will say to everyone, if you made it through the year, give yourself a pat on the back. We all deserve it. And what has it brought us in Zcash land? We have seen 7 zcashd releases in the past year, since this time June last year, when we would have been at ZCon. We have had Zebra has been doing a lot of fun on their side.
Yeah, so we've had about 10 alpha releases since December when we released our first alpha. We wanted to get into a rapid release pattern so that we just got used to the process of releasing updates, and they became fairly relaxed and casual. So we've been releasing one every fortnight or so, every 2 weeks since December.
Yeah, nice, good cadence. And if you hadn't noticed, we've had 2 network upgrades in the last year too. So Hartwell went out, Canopy went out. They were both deployed relatively straightforwardly, and the next network upgrade is well underway, as several previous speakers have mentioned. But yeah, there's plenty of stuff going on.
So at the Zcash Foundation and with Zebra, we've been spending a lot of time working on validating the consensus rules. We've been focusing on the latest network upgrade 5, because that's where most of the new code and the new designs and most of the risk is. We've also been validating Canopy and previous network upgrade consensus rules. Zebra is built on a concurrent microservice stack. So we have a bunch of services that each do their own thing and handle requests and send responses back to the rest of the application. We've been spending a lot of time working on robustness so that it mostly doesn't crash. And actually, to be fair, crashes are very rare. And we've been working on improving the concurrency of the network stack so that it doesn't hang, but it just keeps on going. We've been doing a bit of work on node monitoring. We have a tracing and metrics implementation for a lot of really interesting statistics, and we have a bunch of dashboards in our repository. We've also done some work with the zcashd team to make sure that we present the same metrics with the same names so that you can use the same dashboard if you want to compare zcashd and Zebra. Under all of this, Zebra's written in Rust using async futures and Tower services. Tower services were originally designed for servers that were a little smaller and perhaps a little less complex, but we've found them quite successful doing what we're doing. Zebra is mainly written in Rust with Rust dependencies, but we have a few small C++ dependencies, including the Zcash script implementation and the RocksDB database for our persistent state. In NU5, we have Rust dependencies like the Halo 2 crate and the Orchard crate from ECC, the Zebra Zcash libraries for non-malleable transaction IDs and for chain history, also from the ECC. And we have a bunch of cryptographic dependencies. We have asynchronous batch cryptography, which really does speed up the validation of signatures and of proofs. We have the Zcash specific ED25519 implementation that came in a recent network upgrade. And we're just introducing a canonical jub we're just upgrading to canonical jub now for network upgrade 5. Pass over to you, Strad. Oh, right.
You got one more slide.
So this is a comparison of how batch verification improves ED25519 verification speeds. We get, I think, about double the speed if all of the signatures are made with the same public key, which is common for very large transactions that are produced when people roll up a bunch of different outputs into the same transaction. But in general, we still get a speed up if we're using a bunch of different public keys.
Very good. On the ECC side, as much as I wish that was elliptic curve crypto that we got to spend most of the time on, it does mean we have some C++ work to do because, of course, as many of you know, Bitcoin Core implementation, Bitcoin D, is the grandfather, the historical basis upon which zcashd builds. So in addition to over the last year, we obviously rolled out within the last year, the Canopy network upgrade consensus rules. This time last year, we were a couple of days away, I think, from Heartwood activating. So yeah, it was mainly that network upgrade came in last year. We made a bunch of reliability improvements to the code base, shifting to using C++ 17 and Clang 11 throughout as a single baseline, and also to bring us onto the same set of sort of dependencies. So everything is built with LLVM under the hood then, because we have a hybrid C++ and Rust architecture with more and more Rust oxidizing the code base as we can. Also added in the little party popper for finally getting rid of one of our larger and hurrier dependencies from the stack. On the R&D side of ECC, we've obviously had the work that you've heard in previous talks about working towards private scaling, as was originally talked about at ZCon last time, which has led to Payload 2 and Orchard. And then some side work on programmability, zero-code shielded assets that was mentioned in the one of the earlier talks today. And then a lot of refactoring. We did, there was a lot of technical debt that we took on in the process of doing sapling that needed paying down in terms of the Rust cryptographic crates and like making their architectures easier to use and more modular and so on. So we spent a large chunk of late last year pulling those pieces apart. And some of that is what's actually ended up in pieces that can be used by Zebra as well. Made a bunch of backend improvements to Rust crates to facilitate mobile wallet development. The data access API was something relatively low level, but that took was a big lift from some of the other core team engineers to make wallet developers' lives that bit easier. And we've got some stuff on wallet syncing performance that we have underway. A bit of stuff, we spent some time working on transparent Zcash extensions, which is a WIP, a work in progress zip for making it easier to plug pieces into the network, into the consensus protocol that understand how to do balance. So in the way we have the sapling pool and the orchard pool, and then we have transparent addresses are a pool. We know pretty well how to plug in shielded pools, but the transparent side didn't really have very good support for that. So TZD sort of are the thing we're working on the side. They're not yet NU ready, but we're hoping they can be soon. And then, of course, top it all off this year with the actually implementing NU5. So we have the Halo 2 and Orchard, as I mentioned before, and also this non-malleable TXIDs, which I wanted to just delve into briefly as our little bit of technical interlude. So currently, Zcash transactions, V4 as the prevalent format on the network, you have a byte encoding that's shipped around the network, and that encoding contains potentially all the bits and pieces that your transaction may want to use. So your transparent inputs and outputs, your Sprout joint splits, for those of you who are still using it, and then the sapling spends and sapling outputs. And all of those contain various pieces that encode the effect of the transaction, the action it takes on the global ledger. And then they have various pieces that authorize that action. So that's where your hardware wallet comes in to make its signature, or your triple core 8-thread processor comes in to make its proofs or whatever. And then all of that gets encoded into a byte form, and that just gets hashed directly, and that forms the transaction ID. That's the way it was done in Bitcoin. That's the way we inherited, and that's the way it's always been done. The problem comes where you have to be able to apply signatures, and you have to be able to sign something. So the signatures themselves are inherently malleable. And what I mean by malleable is that you can take a signature away and replace it with a different signature, and it will still authorize the transaction. But because those signatures are included in the digest that produces the transaction ID, it means that if you modify any of that data, the transaction ID changes. Now, that causes a problem where you have off-chain code that relies on the transaction identifier being a stable identifier for the effects of a transaction. Now, this is something that you may recall Bitcoin had with also had a problem with, and they wanted to put out like layer 2 protocols like Lightning. And the solution to that was a non-malleability fix where you basically take those pieces out from under the transaction ID. And so what we're deploying in NU5 is effectively the same thing. So we've now split up the transaction in V5 into effecting data pieces and authorizing data pieces. The effecting data pieces are hashed together in actually in a little Merkle tree internally, so that you can bind individual pieces to the transaction ID. So you can say, like, given this transaction ID, you know that this nullifier occurred in that transaction. And then, so that binds all those pieces. And then all of the authorizing data, the proofs and signatures, are given an auth digest. And so if you make any changes to that logic, the auth digest will change. But because all of the signatures and things in there bind the effects of the transaction, but don't affect any of it, the transaction ID doesn't change. So the only way the transaction ID can change is if you change one of the outputs, who it's going to, which is something you wanted to change with. And so the thing that you then have to do, obviously, is you still need to bind the whole transaction into the blockchain. So we currently have the transaction IDs get bound into this hash Merkle root in the block header. And then we happen to have this other field that we stuck in at the beginning that was reserved, and then it was the sapling root, and then it was the light client root, and we're changing it one last time, we promise, to be a hash of block commitments. We've turned it essentially into a linked list, so we can indefinitely append to it in future. And so in that one, we now have two parallel trees, one of which contains all the transaction IDs, and the other one contains all of the authorizing data. And those together bind what actually goes into the block. The bytes that go into the block are fully specified, while the transaction IDs can then retain their effective semantic meaning. Yeah, so yeah, that's a fair bit of fun. So how do we get all this done? is a reasonably good question, and I think it really starts with the interactions that we have as a development community. Yeah, I think most of our interactions happen over GitHub, I would say, wouldn't they, Teor?
Yeah, gosh, I feel like I live on GitHub some days. So we spend a lot of time talking back and forth on GitHub issues and GitHub pull requests. I've got an amazing, the Zebra team's got an amazing amount of help from various ECC developers who drop in and help us clarify the spec, or we do things we maybe shouldn't be doing, and spec clarifications appear and help us understand what the consistent way of doing things is. So that's been really amazing and really helpful. We also spend quite a bit of time, so every fortnight there's an arborist call, and the developers spend time discussing recent changes and planning for upcoming work. Those have been really helpful, particularly since we switched them to happening every 2 weeks rather than every month. And then finally, there's a Discord server, the Zcash R&D Discord, which we've been talking through on a bunch of different channels, the node implementations, changes to the spec, and a whole bunch of different things we'd like to see happen around Zcash. And that's been really handy for having longer conversations about issues that perhaps don't fit in a video call or don't fit on a particular change request or spec change.
Yeah, it becomes a lot easier to just sort of ad hoc figure things out in a little slightly more ephemeral sense, but without the overhead of a meeting. So big kudos to Hudson James for setting up the Discord server. It's been invaluable to moving things along. We've heard a bit about shared dependencies, and yeah, there's quite a lot that is sort of independently developed by us, but there's a reasonable amount that we're starting to share as well. And we have a nice DAG that's the wrong DAG. That is not the dependency DAG. That is the ECC core team to-do list. It's a little big. It's a bit of a DAG. But the thing that there we go. As you can see from here, we have so the yellow gold dependencies here are things that have been developed by ECC, and the Dodger blue dependencies are from the Zcash Foundation. And you can see the sort of the inception here of BLS-1231 and JubJub that sort of underpins a lot of the existing Zcash stuff, with Halo 2 and Orchard sort of branching off at the moment as the new piece that's coming in, and then zcashd with all of its tendrils sort of absorbing all of the pieces together at the top level.
And with Zebra, you can see that some of the Zebra crates there that are independently usable if, say, you wanted to connect to the network or model the data in a Zcash blockchain. And you can also see the ED25519 Zebra cryptographic and red JubJub dependencies, which have been incorporated in both implementations recently. And you can also see how we're reusing the script implementation from zcashd, because developing our own we thought was quite risky. We thought that there was a good chance that we wouldn't validate scripts exactly the same way. And it was going to be a lot of work to try and make that happen.
Yeah, and as you can sort of see, the dotted lines here indicating where more dependencies are sort of being forged in between these two stacks. It's been very interesting to sort of take the step of figuring out the core bits we depend on and the ways in which we can make them easier to depend on. So like libzcash script for instance, began its life as libzcash consensus over in Bitcoin land. But obviously there's a lot more to consensus here than just transparent signature verification. So the process of actually extracting that to use for Zebra was very nice on the zcashd side to sort of help modularize it and sort of beat it into shape after having fallen into disrepair.
And you can also see where Zebra is just about to depend on sorry about that, Strad. You can also see where Zebra is just about to depend on Zcash primitives for transaction IDs and Zcash history for the Heartwood chain history and the upgrades that are going to happen in NU5 to the chain history with Orchard.
Yeah. Yes, the other component of something that really helps us out with keeping things in sync and going is what I will sort of roughly class as integration testing. But the sort of the three things I can think of in terms of the ways that we interact pretty well here is, well, just by having Zebra around, we have a more active test net. And so, deploying, as Deirdre noted in a previous talk, Zebra at one point had was quite impactful on the network. And so people now notice when there's a problem with it, with the network. The testnet in a box is another thing that has come out of the ECC's Dev Infra team, actually, and is, I think the first team to be using it is the Bolt Labs people working on Bolt being a layer 2 chain mechanism for performing transactions off-chain, which would be enabled. It wouldn't be able to be deployed without the non-malleability change that we're deploying in NU5. So having that logic to be able to just like throw something out into its own private network and bash it to pieces is useful for making sure things don't sort of fall by the wayside. And I think in theory it's possible to run this with Zebra D as well. I'm not sure if that's been done yet.
We haven't checked yet. It's on our list of things to do, but we've been mainly focusing on validation and fixing bugs that we already know about in the network stack.
Yeah.
And that's a good segue into the Ziggurat network integration tests. We have opened, gosh, it must be about 10 different bugs in the Zebra network stack, if not more, because of the work of the Ziggurat team. One of the reasons for that is that Zebra has a totally new concurrent network stack. And so there are all sorts of assumptions that we've built into developing it that we now need to check against what zcashd does.
So, is it working? Is a good question. How do we feel about the way that the collaboration is going? And in particular, what do we think is the as Deirdre also and Stephen mentioned in the nut planning one, there is some there's obviously discussion about like how much sharing should happen, and where does it make sense to put that line. I think Teor, if you want to take care, because you've got probably the best view, I think, as someone who's had to come in and start trying to operate within an existing ecosystem.
Yeah, so I think sharing has definitely been good for the Zebra team, particularly where the components don't need changes to be made more concurrent. So one of Zebra's goals is to be a concurrent node implementation and to use however many cores and whatever quality of network connection you have. And so where the protocol and where the dependencies don't particularly need changes for concurrency, it's been very easy for us to just adopt those dependencies straight up. And we've been doing that more and more so that we can prioritize working on concurrency where it really does matter. But in some cases, we've made changes. We've introduced batch verification services for the signatures and for proofs, or at least for the sapling and sprout proofs. And then I believe those are available for the zcashd team to use.
Yeah, obviously just have to get it on our pipeline to put them in, but no, the presence there is absolutely beneficial to us being able to know that there's a potential performance optimization just sort of sitting in the pocket that we can pull out when we have the time to do so.
As an example of some shared dependencies that we absolutely did want to depend on, the history commitment trees that were introduced in Heartwood and will be modified in NU5 are a dependency that doesn't really benefit from concurrency because you have to know the entire blockchain to commit to the history. For Halo 2, that's a bunch of cryptography that it's probably best just to do once for now. For non-malleable transaction IDs, again, there's nothing we can really do to make them more concurrent. And it's been very useful for us to adopt that work and do those calculations rather than trying to implement a hash tree ourselves. But that's something that we might do in future if we decide it's useful. Another advantage is that we can share the same dependencies for signatures that absolutely do need to be exactly the same across the all implementations. So ED 25519 and JubJub as well. You can see a bunch of other dependencies there. It certainly has helped us make our implementation a lot more robust because we're testing against somebody else rather than just working with Zebra's own assumptions about how the network should work.
Yeah. And that actually brings us nicely into here because from our perspective, having a separate implementation has been really beneficial to the Zcash, the health of the Zcash network as a whole. Yeah, the number of spec bugs that the Zcash Foundation team has opened, I don't really want to go back and look at how many, but it's absolutely fantastic having another set of eyes on the protocol who are implementing it from scratch in a sense. In that, it's very easy when developing developing the changes that we're making. Like, we have a full understanding of the stack that we're working on, and we do our best to document them as clearly as we can for the changes that we're making. But having other people looking at them and going, no, this is not actually clearly specified, or there is a question about this piece here, or oh, there's a typo here, and if it were implemented as is, it would break the network. Yeah, it's been great. Yeah, the fewer hidden assumptions as well, in that, yeah, because of Zcash's provenance as a Bitcoin fork, we inherited a lot of implicit consensus behavior that we haven't spent a lot of time accurately documenting it because we've been doing ZK proof stuff, the fun stuff on side. But those parts of it, both the consensus level Bitcoin inherited pieces and the non-consensus, but the nodes can interact poorly if it's not well specified and understood. The work that has occurred as a result of having a second node implementation means that those pieces are much more clearly documented, and we can start to sort of create more shared specifications for those pieces that thus far have been left undocumented.
Another thing that we've been doing is that we've been adapting protocol changes so that they are able to be verified serially or concurrently. So, for example, we added a field to the transaction version 5, which is being released in the next network upgrade, so that it was easier to verify those transactions concurrently.
Yeah, like taking advantage of the fact that, yeah, we have different stacks, we have different approaches that we're taking, and so we see different effects of the same consensus rule changes, and can bring our own perspectives to bear to make the whole thing much more robust and pretty, ideally. Yeah, there we go. So what's next for the teams? We've got another year ahead of us, unfortunately.
So for Zebra, we're going to be starting work on our transaction mempool, which is how nodes gossip and share unmined transactions. We're going to start work on Zebra client, so users can send transactions using Zebra. We're going to finish up validation for the next network upgrade and fill in the gaps from previous network upgrades where we haven't quite finished up the validation yet. But Zebra is already checkpointing on the Canopy network upgrade. So everything that's been removed before Canopy, for example, new, what is it? Part of Sprout got disabled, and I can never get this right around the right way. Creating new Sprout outputs got disabled. So you can spend Sprout, but you can't create new Sprout outputs from transactions. So we don't have to worry about that in Zebra because it's already been disabled, and we are checkpointing past the point where there were any more of those.
Yeah, on the zcashd side, well, we obviously have to finish up NU5 as the most pressing piece to get that out the door. And then following on from that, I think the two biggest things that I can think of that we'll be working on over the next year for zcashd will be significant network stack updates. So we have a bit of a backlog for upstream backports from Bitcoin Core, including various peer-to-peer layer optimizations that upstream have made that we haven't really needed yet because we haven't had quite the same kind of volume going across the network. But things like their version of compact blocks, different from our compact blocks, which are at the light client layer. Compact blocks of the form of like just don't send the whole block when a new block comes in. Do a diff on the mempools to figure out what the pieces are, which directly ties into zcashd and versus Zebra D and how their mempools operate, which will be fun. And then the other piece that we at ECC have wanted to do for a long time is replace the C++ wallet internals with something better, and I think it's possibly going to happen. Yeah, possibly, maybe. Fingers crossed. Hope Stephen doesn't yell at me. Yeah, if and when we do replace it, it will be replacing currently the Berkeley DB C++ based wallet inside zcashd. It would still live there for a while, but we would have a parallel Rust wallet, ideally basically the same code base as what gets used for the Zcash light client wallets, because the wallet logic can be the same. It doesn't really matter how it talks to the network and gets its data. So more modularization, more abstractions there, and building pieces that we can then bring into zcashd and reuse in that way. And then eventually maybe turning off the C++ wallet. We'll see how lucky we get. And then as far as the Zcash network globally goes, NU6. Going to have a planning party for that, I think, in the moment that NU5 gets out the door. And yeah, if anyone is interested in thoughts for NU6, now is absolutely the time to be suggesting things, because we would be, multiple months out from sort of any sort of thoughts about feature planning or feature selection. So now is absolutely the time to be going, hey, here's something I would like to see in the next network upgrade or a following network upgrade.
And as part of zcashd backporting network stack updates, Zebra will be implementing similar updates, or at least deciding if we want to support those new features or not. And so that will mean upgrades to the network protocol itself and a bit of back and forth working out if we want to adapt any of those designs to Zcash.
Yeah, there may easily be pieces that make sense in our contexts that we may as well do at the same time. Well, that I think is the end of the slides. So let's go to the chat for questions. I see one question, which I'll I think Teor for. Could you detail the Zebra database and the script dependencies, please?
Sure. So Zebra needs some way to store change state so that when you restart Zebra, it can start off from the point that it left off. So the Zebra database dependency is RocksDB, which is a C++ database that is heavily concurrent, which is one of the reasons we chose it. And we use that via a Rust crate that provides a safe Rust interface to the database. The Zcash script dependency is a dependency, I think we talked about it earlier in the talk, but it's a dependency that the zcashd team split out of their library, and similarly, Zebra uses a safe Rust interface to that script dependency because script validation is complicated. It's a little language all by itself, and one of the risks of independently validating scripts was that we wouldn't get it quite right, and there'd be some edge cases that might cause a consensus split. So we considered that until we had time to do a lot of testing, we would just use the shared dependency. So I think the next question is about Zcashd, and it is, we'd appreciate an update on the current state of Zcashd DevOps, including automated performance testing, changes to the validation and unit test, deterministic build, toolchain upgrade, image signing, binaries distribution, and support for virtualization. Please feel free to hit a few of those points, Strad.
Really got the toolbox out there. Yeah, so I'm not the one best equipped to talk to some of those because I'm not on the DevOps team. I will direct most of those to Marshall in the Discord channel, but I will say that the DevOps team at ECC has been doing very good work on several of these fronts. The one I will call out specifically is CI. When we launched Zcash, none of the freely available open source like testing things could at all handle Zcash because you needed like 4 gigabytes of memory to create a transaction, and like nothing would do that at all. So we had to spin up our own CI system based on BuildBot, and we've used that for the last 5 years, and it is showing its age. So the dev infra team has been working on a new system for the past, quite some time now, based on Tecton and I believe Kubernetes. I'm just throwing up buzzwords now. But you'll have seen all these do not merge PRs opening and closing for Zcashd, which is them testing it in production, but on non-production PRs. So that's coming along very nicely. Deterministic builds, Zcashd has always been deterministically built. If you build it, well, the releases are. If you build it just straight from build.sh, it won't. But there is a Gitian build system that we use for all of our releases. So we've always had deterministic builds in there. And I think the other one I'll say is, yeah, there's no planned changes to the way in which we sign and distribute binaries at this time. I will, yeah, their questions I will leave to the dev infra team.
I might as well answer a similar question for Zebra's CI. Since we're only doing validation, we haven't had very many problems with memory or processor capacity. We do spin up our own Google Cloud jobs so that we can get a quick idea of whether the tests are passing. But we've been fortunate so far that the standard GitHub Actions can just handle what we're doing. I imagine that could be a bit different as we start our client work and start to generate proofs and transactions. And I guess we'll be talking to the ECC team at that point.
Yeah, we will. It's less of a problem now, I think, like our Rust dependency. So we have our zcashd CI stack, I should probably clarify, and that uses BuildBot, and that's all that stack, because that's the consensus node. That's the one that's the most critical to make sure we get right. But all of our Rust dependencies since Sapling, they just run on GitHub Actions, and thus far. And the use of at Sapling, the big performance improvements it brought along meant that we didn't actually need to hit those kinds of memory usages and things. It's still slow because you're operating on a tier of availability that is, it's geared towards open source code, and we are open source code, but we're a bit on the heavy side as far as we're not a CLI tool, but yeah. It's definitely doable, but you may still want to look at a more custom setup if speed is of the essence.
I'll just read out the next question I think Strad might be the better person to answer this. Is the transaction malleability fix only for future hardening, or have transactions been malleated in the past causing problems? If so, do we know why? Was it maliciously or accidentally, given that we don't have a Lightning Network or equivalent?
So that's a really interesting question, because the answer is we can't know. Or at least we can't know without anyone coming forward. So the transaction ID malleation problem is a problem basically in the interval between when a transaction gets submitted to the network and when it gets mined into a block. That period of time is inherently out of consensus, outside of the consensus rules. So we can't observe it. All we can see is what ends up in the block. And once it ends up in a block, it's just whatever TXID, whatever binary bits of the transaction are in that block is what it is. So the logic that that we're introducing here is for a problem that we know and the ecosystem knows is a problem for off-chain protocols like Lightning, like Bolt, where specifically when you have two parties off-chain collaboratively making a transaction, they need to agree on certain pieces of state off-chain. And for example, Alice and Bob might be making a transaction. They agree on like funding this this channel. And then Bob comes along and goes, cool, I'm going to sign the redeeming transaction. And because it's game theory and the way it all works, the first transaction you have to sign is one that gives Alice all the funds after a timeout. And Bob goes, cool, that's going to spend the ones from this transaction, signs it, done. Then Alice could go and change her signature on the first one, which she can do. She can re-sign it, which would change the transaction identifier of the first transaction. And if that gets into the chain, Bob then has no way to do the reclamation transaction because it's signed for a transaction ID that can never exist. Because to create that transaction ID would mean double spending the inputs the first transaction spent. So but it's not a problem we can see on chain because all that the chain sees is a transaction got mined and it sent the funds to a place that then after a certain amount of time, they timed out and were sent elsewhere. So it's something that a lot of people have thought about off chain. It's not something that we would see on chain, but it's something that then gets eliminated as a problem on chain by this change. Cool. I don't see any other questions. So yeah, I guess with that, we can wrap up. Thank you again to everyone who's been putting this on. It's been very nice to finally be back around everyone, virtually at least.
Well, thank you, Strad and Teor. And Strad, I love the color you chose to represent the foundation on that dependency graph. A couple of things that stood out for me from that presentation were the benefits of having separate implementations of the Zcash protocol, which is something we expected would accrue from the Zcash project, but it's still gratifying to see our assumption borne out even before Zebra is ready for production deployment. It's also really interesting to hear about the benefits of Ziggurat and what that project's bringing, which was the result of a major grant, which highlights the benefits that accrue from having a mechanism for funding third-party work. At the risk of repeating myself, if you have an idea for how to improve or enhance Zcash, please go ahead and submit a grant application to the Zcash Open Major Grants Committee. Well, that's a wrap for the first day of ZCon. To those of you who are watching live, good morning, good afternoon, good evening, and good night, depending upon which time zone you are in. And we'll be back tomorrow at 2 p.m. UTC.